All right, so we're going to start with lesson 9.7, graphs of quadratic functions. And we're going to be studying the parent functions. So for the first one, the question is, write an equation that describes each relation. So we know that this one, let me do it in a different color, maybe. This one is what? F of x equal to x squared. Y is equal to x squared. Y is 4. X is 2 to the second power is 4. Y is 9. 3 to the second power is 9. Now, this one is going to be f of x equal to the absolute value of x. What's the absolute value of y? Is the absolute value of x. X is -1. What's the absolute value? 1. What's the absolute value of -2? It's 2. And this one over here, f of x equal to the square root. What's the square root of 1? Y is equal to the square root of x. What's the square root of 4? 2. The square root of 9? 3. The family of the quadratic function is always possible, is all possible quadratic functions. It says that the quadratic function, no, hold on, the parent function is the simplest form of what we call, of what we would call a family of functions. The parent function is the simplest form of what we would call a family of functions. It says that the family of quadratic functions is all possible quadratic functions. The family of quadratic functions is all possible quadratic functions. We can describe the entire family of quadratic functions in terms of the parent function. Let me write that down. We can describe the entire family of quadratic functions in terms of the what? Of the parent function. Okay? But how do we do that? So every quadratic function let me focus. Okay, better. So every quadratic function every, every quadratic function is a mutation. We can say mutation, we can say offspring, we can say a baby of the what? Of the parent function. Every quadratic function is a mutation, offspring, or a baby of the parent function. So we're going to be looking at the possible mutation. And here's what we call transformations. Okay, we started with parent functions, which was this part. Now we're going to look at transformations. Those are the possible mutations. Every quadratic function is a mutation or is a baby of the parent function. And we're going to look at the transformations. So we have so I have this one here is it starts in 0, 1, and we have 1, 2, so it's 1, this is 2, and we have a 3, 4, 5, we have a 2, 5, 2, 5, and here I have a 1, 2. And on this side, I have -1, wow, let me get my glasses because I cannot see that, okay? On this side, I have a -1 and a 2. -1 and a 2, okay? And here I have a -2 and 5. So this is going to go like this. All right, so we're going to square the input and we are adding 1. Square the input, which is the input is 0, it's going to be 0, and we're going to be adding 1 is 1, the result. Square the input, 1 times 1 is 1, plus 1 is 2. 2 times 2 is 4, plus 1 is 5. So what we have here is fx is equal to x squared plus 1. And notice that this one is going up. We're going up 1. Now, let's do this one over here. So we have f of x. I have f of x here too, but here's going to be our origin. We're going to have 0, -1, and we have a 1 here, a 2, and a 3. I have a 1 and a 2. So I go from here to 1, 0, and 1, 2, and 3. I'm going to 2 to 3. And on this side is going to be -2, 3. So here's my graph. So I'm going this way. So this one is going to be input will be 0 and the output is 1, right? Which is this one. Right, so then we're going to square 0, and what are we doing? Subtracting 1. And we're going to subtract 1. So on this one, we square the 0 and we subtract 1. That's why it's negative 1. We square the 1 and we subtract 1. So we get 0. We square the number and we square the 0 or the input. 4 minus 1 is 3. Okay, so our function is going to be x squared minus 1. Okay, and notice that here says down 1. So we have x squared plus 1 equals up 1, and negative 1 equals down 1. So it seems like we're moving the parent function up and down. So when we're moving the parent function up and down, this is what we call vertical shift. Okay, this is what we call the vertical shift. When we're moving the parent function up and down. Let me write it down. Moving the parent function up and down. That's what we were doing. Take this one, we move it up and we move it down. This is the parent function. And here's the transformation. This is the transformation, okay? Now, let's do the second transformation. We had the first one here, and let me do the second one. So the second one is going to be, we have f of x, here's our function, and this is negative 1 comma 0. That's what this point is. This one is 0 comma 1. And this one is 2, 3, and 4, 1, 4. Okay? And over here we have negative 2, 1. And this one is negative 3 and 4. Negative 3 and 4. So we're going to start over here and we're going this way. Right? So let me just write this down. If we look at this, the input and then we add 1 and then a square. So what is this for? This for is the input, then we add 1 and then a square. The input is 1, add 1 is 2, a square is 4. Input is 0, add 1 is 1, a square 1. Okay, so this function is going to be x plus 1 squared. okay? Now, notice that it's going to the left and it's plus 1. So this one is going to be like this one, but it's going to start where? Over here. So it's going to be 1, it's going to start right here, 1 comma 0. And it's going to do 2, 1 and 2, 2, 1, and it's going to be 3, 2, 3, and 4. It's going to be 3, 4. And on this side, we're going to have 0, 1, and we're going to have negative 1, 4. And I'll tell you the function. So it's going to go this way. So it's going to be the input is 1 and the output is 0. Right here, the input is 2 and the output is 1. So what do we do there? We subtract and then a square. So it's going to be x minus 1 squared. We subtract 1, 0, and then we square 0. Subtract 1 is 1, square 1. Subtract 1 is 2, square 2 is 4. Notice that when it's to the right, it's negative 1. And when it's plus 1, it's to the left. Okay? And this is what we call the horizontal shift. Horizontal. It's on the x-axis. Look at here. This is on the y-axis. You guys see that? Here's on the y. This one is on the x-axis. And we're going to be moving the parent function, moving left and right. Okay? Now, let's do number 3. Remember, we're doing transformation. Every quadratic function is a mutation or an offspring or baby of the parent function. And we were looking at the possible mutations. That's what we're doing. So what about the reflection across the y-axis? What about a reflection across the y-axis? What would that look like? So the answer is that f of x is symmetric. So reflection across y-axis does nothing, okay? And let me give you an example here, all right? So we have f of x, here is 0, 0. We have 1, we have 2, 1, 2, 3, 4. The next one is going to be 1 and negative 1, 1 and negative 1, and this one is going to be 2 and negative 4. And on this side we have 1, 2, 3, and 4. So we have both negative, negative 1 and negative 1, and we have negative 2 and negative 4. Negative 2 and negative 4. So this is going to be like this. And how are we going to write that function? This function is going to be negative x squared because it's on this side, the negative side. And we call this one a reflection about the x-axis. Reflection about x-axis. Okay? And it's like flipping the parent function because the parent function is this one. And we're just flipping it. Sorry. Here's the parent function. This one is the parent. So you're just flipping it. Okay? We could refer to it as flipping the parent function. Now, the point here number 4, we have so we have this one 0, 0, and we have that's 1 and 2. So this is 1, 2, and this one will be negative 1 and 2, and the next one will be 2, 3, 4, 5, 6, 7, and 8. So this one will be 2, 8. And on this side will be negative 2 and 8. So let's now we got a input will be a square and then what? Then times 2. That's what we're doing. The input squared is 4. Then 4 times 2 is 8. That's what we're doing. So we can say that this one f of x is what? X squared times 2, which this is equal that if we say 2x squared. We're multiplying it by 2, we're squaring it first and then multiplying it by 2. Okay? Now, notice something here that make a skinny. Okay? And then let me do the other one. So we have 0, 0. We have 1, and this is half. The next one is going to be 2. We have 2. And the next one is going to be 3. This is 3 and this is 4. And it's going to be 3, 4.5. So let's move it up here. 3, 4.5. All right. Now let's do this other side. This other side we're going to have 1, 2, and 3. So in 1 we're going to have -1 but negative. So we have -1 comma 1/2. Now we have -2 comma 2. And then we have -3. Sorry the noise, guys. -3 comma 4.5. So what we have here is kindness. My specialty is not making these graphs, okay? So first, the input 3 and output 4.5, right? That's what we have here for this one. So what are we doing? We're gonna square and then take half. So we're gonna square the 2. 2 times 2 is 4. Half of 4 is 2. We're gonna square 3 times 3 is 9. Half of 9 is 4.5. And look at this. Make it fat. And the equation is going to be what? We could say x squared times divided by 1/2, right? So we're going to say 1/2 x squared. And we call this one the vertical horizontal stretch. Vertical horizontal, vertical horizontal stretch. We're making the parent function fat or skinny, all right? So we are making the parent function fat or skinny. That's what we're doing. This one, we were flipping the parent function. This one, we were moving the parent function left and right. And the one before, vertical shift, we were moving the parent function up and down. Now, let's put all of these transformations together, right? So we have, give me enough space here. Yes, I think so. So we have so what are the ways? Hold on. Let's put all of these transformations together. Okay? And we're gonna answer this question. What are the ways we can transform f of x equals to x squared? So the first one is move up and down. And that one is what? F of x equal to x squared plus k, which was, let me get my my here, the first one. Okay. Now, number 2, move left and right. So when we moved left and right, which is the horizontal shift, remember one is positive but the other is negative, we have f of x equal to what? X minus h squared. Now, flip across x-axis. We said was going to be negative x squared. And the last one, f of a, no, make fat or skinny. So this one is ax squared. So as one statement, we have this. F of x is equal ax minus h squared plus k. And let's work on this. So we have a, the absolute value of a needs to be less than 1 and greater than 0. When that happens, we have a fat graph. When absolute value of 8 is greater than 1, is going to be skinny. And when it's less than 1, it's going to reflect. All right? The next one. This one, we're going to do the opposite of A. Of H, remember. And for K, is going to be positive K with shift up. And negative K with shift down. All right? This is just in one statement. Now, so instead of doing all of this for the absolute value and the square root functions, we will just summarize the transformations. So let me write that down. So we're saying that instead of doing all of this for the absolute value, and square root functions, we will just summarize the transformations. We will just summarize the transformations. So the first one will be the absolute value family of functions. Okay? The absolute value family of functions. So the parent function is going to be f of x equal to the absolute value. And the family transformation is going to be f of x equal to absolute value of x minus h plus k. Okay, that's for absolute value. Now, for the square root family of functions. So this is the square root family of functions. So we have, again, the parent function f of x equal to what? To the square root of x. Now, the family so the transformation is going to be a x minus a square root of h a x minus h plus k. All right,